Good morning everyone. Here we go. So we are taking now the next topic, a polynomial. So in a polynomial we studied about that what is the polynomial and how many types of polynomial according to their classification based on their terms and based on their degree. So here we go. Now we all know that the polynomial, which is the combination of the algebraic expression along with their variables with mathematical operations like a plus b, or you can say 2x plus 2y. So now in that conditions we can see that the x and y, all those value which having no value actually, because there are x and y, it can be anything, so there is no perfect numerical value for that x and y, so we call them variables. If any particular value is there, for an example 5xy square, so that 5 is the numerical number, we call it, this is a coefficient of xy square. So first let's study about these polynomial and their types. So as we can see here, a polynomial is an expression. What is there? It is an expression. Now we know that expression and equation, there are two different types of words. Expression, which is just a combination of the variable and the coefficient along with the mathematical operation like plus, minus, multiply and divide. And on the other hand, it is equation, when there is a equal sign between the expressions like x plus y is equals to 10. Now there is an equal sign. If in an expression equal sign is there, so we call them, this is expression, this is an equation. And if there is no equal sign in between, so we call them expression, right? Now a polynomial is an expression made with constant, it can be any number without having any variables and exponent. Now we all know that the exponents are basically the powers. X square, that means the exponent is 2. X cube, that means exponent is 3, like that, which are combined using addition, subtraction and multiplication. So these addition, subtraction and multiplication are mathematical operation. So here in this case he is saying that the polynomial is an expression with constant variable, exponents, and the combined using the addition, subtraction and multiplication. Let's see an example. 2x square minus 3. Now if you are seeing this 2x square minus 3, this is called an expression, right? So in an expression it is coefficient of x square, variable and the constant value minus 3. So the combination of all these variable, coefficient and the constant value is called polynomial, right? Poly means many, it can be one term as well and more than one term also. So it is expression and this expression is called polynomial, correct? Alright, now it is combined by using addition, subtraction and multiplication. As we can see here, in between these two terms, 2x square is one term, minus 3 is the second term. As we can see, in between there is a minus sign, so that means the two terms can be combined with minus sign as well as plus sign and multiplied as well, but not division. It is written but not division. That means if anything which is coming in denominator, that means in division, that is not polynomial. Alright, now next, the exponents can only be 0, 1, 2, 3 and etc. So what is the mean of that? Look at this. An exponents, we all know that the exponent is the power, right? So the exponent can only be 0, 1, 2, 3 and so on. That means exponent can be only whole number. These all number are whole number, it can be complete. So that means whatever the power which is exponent is complete in power, like x raised to power 1, power 2, power 3, power 4. It cannot be like power 1.5 or power 1 upon 2 or power minus 1 upon 2, correct? So every time the exponent on the power will be in a whole number only, 0, 1, 2, 3 and so on. Is it clear? All right. Next, a polynomial cannot have infinite number of terms. Infinite number of terms. That means in a polynomial there are some certain terms only. It can be 1, 2, 3, 4, 5, but it cannot be infinite. For an example, if we write it anything like x plus y plus z plus dot 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 n, this is not a polynomial, because we can see here there are not a certain number, they are infinite terms, so we can say these are not polynomial. Okay, so here the first questions arise that if the particular thing is polynomial or not, how can we decide that the particular thing is polynomial or not? So all these three combination, as we can see that all those polynomial, all those expression are the polynomial which have some certain terms and which have the exponent in the whole number and which is following this first rule, which have the multiplication, addition, subtraction but not division in variables. So here it is, exponent is 0, 1, 2, 3, that will be, okay, look, 5x y raised to the power 2 minus 3x plus 5y cube minus 3. Now we can see that these are the four terms. Look at this. First term is 5xy square, second term is minus 3x, third term is plus 5y cube, and the fourth term, which is the constant value, minus 3. So these are the four terms, correct? So it is actually the variable or the exponents are in perfect whole number, y square, y raised to the power 1, y cube. So these are polynomial. We can say these all are polynomial because the powers are perfect in a whole number and no term is like there is a finite number of terms. On the other hand, we can see that these are not polynomial because here the exponent are coming negative, minus 2. So we all know that when there is a minus power, for an example, x raised to power minus n, is it actually 1 upon x raised to power n? So here the power or the base are coming in denominator. So whenever this kind of condition is there, when the thing is coming in denominator, that is not a polynomial. So that similarly, if y raised to the power minus 2 is not a whole number, we all know that minus 2 is an integer, not a whole number. So that's why this 3x y raised to the power minus 2 is not a whole number. That's why it is not a polynomial. Second, 2 upon x plus 2. Now here also the variable x is in denominator. So that's why it is also not a polynomial, because we can write this situation as 2 and x, because it is in denominator, so it is minus 1. So that's why the power is not a whole number. That's why it's not a polynomial. Is it clear? All right. Now next, now our next slide is different type of polynomial. We already discussed that there are some different types of polynomial based on their terms and based on their degree, right? So first we will study about based on their terms. Here it is. Let's take it only this one. Look, it is a classification based on their terms, right? We all know that the terms are the algebraic combination with the plus and minus sign. So here first is monomial. Now the word is saying mono, that means when the number of term is 1, we call them monomial. So in a monomial, the polynomial having only one term, when there is only one term, we call it monomial, right? Let's take an example, 4x. There is no plus minus sign after 4x. That means it is only one term, which x as a variable and 4 is the coefficient. Second, 8y. It is only one variable, y, and along with the coefficient, which is 8. So that means it is also a monomial. Clear? Now next, binomial. Now the bi means when the number of terms are 2. So when the polynomial having 2 terms, it's called binomial. For an example, 2x plus 6. Now in this expression we can see that 2x plus 6. There are two terms. 2x is first and plus 6 is the second one. So these are two terms. That's why it is a binomial, right? Next, 25y minus 25. In this situation also we can see that 25y is the first term and minus 25 is the second term. So these are the two terms. That's why it is binomial. Is it clear? Okay. Now what is the constant in this expression? Minus 25. Minus 25. You have to see the minus sign also. Every time whenever you have to ask that what is the constant term, if there is a minus sign, then you have to tell the minus sign also, minus 25. Now third is trinomial. Now we know that the tri means 3. So when there are 3 terms, we call the kind of polynomial is trinomial. So polynomial having 3 terms, then it is trinomial. For an example, 2x minus x cube plus 25. 3 terms are there, 2x minus x cube 25. So these are trinomial. Similarly here x cube 5x square minus 8. These are the 3 terms. That's why it is a trinomial. Hope you all understood this monomial, binomial and trinomial, and these all are basically the type of polynomial. That means monomial is also a polynomial. So don't get confused that monomial is just a monomial. These all are basically the type of polynomial only, right? So monomial is a polynomial. Okay. Now we should move on to the next slide. We have done the first classification, that on the basis of their terms. Now we have to classify the polynomial on the basis of their degree. Now we all know that the degree means the highest power of the variable. So in that case, when we are finding the highest power of the degree, or you can say it's a maximum power of exponent, maximum power of exponent is degree. Look at this situation. First, constant polynomial. Now here is the constant polynomial. Now we all know that the constant means when anything is fixed. That means it will be not change after a time or after a certain period of time. So that means the constant value or constant number don't have any variable. So all those constant number which is having only and only numerical value, like no variables are there, we call them constant polynomial. So polynomial having degree 0, that means it is not having the x variable which is 0, so that means it is called 0 also, or we can write it minus 5x raised to power 0, right? So we can call it constant polynomial or degree 0 polynomial as well. So now example 32. In 32 there is no variable, so we can call it constant polynomial. Similarly minus 5, they don't have any variable here, so we can call it minus 5 also a constant value or constant polynomial or 0 degree. Second is linear polynomial. Now we know that the linear means when there is variable having the power 1. That means 1 degree of equation is called linear polynomial. So when the polynomial having the degree 1, that means x plus 5. Now we can see on the variable there is no power. So when there is no power, we can consider it as 1. So x plus 1, x plus 5, because x raised to the power nothing here, so we can consider it as 1. So x raised to power 1 plus 5 is considered as linear polynomial. Similarly 6x minus 3, on the x we can see there is no power, that means it is also 1, so it is also a linear polynomial. Is it clear? That means linear equation only and only having 1 power. Second, quadratic equation. Now we all know that when there is a maximum power 2, we call it quadratic polynomial. A polynomial having degree 2. So when the maximum power is 2, we can call it quadratic polynomial. So in the quadratic equation, you can see that 2x square plus 3x minus 8. What is the maximum power here? 2. So that means it is a quadratic equation. Is it right? When the power 2 is there, it is called quadratic equation. Now the third is cubic. We all know that the cubic is when the maximum power is 3. Polynomial having the degree 3. So this is a kind of polynomial which is having the degree 3 equation. So that means degree 3, example 6x cube plus 7x square minus x and minus 6. The maximum power is 3 here. That's why it is a cubic equation, or we can call it cubic polynomial. Correct? All right. And the last is by quadratic equation. It is written by, that means quadratic equation is having 2 power. When it is by, it becomes power 4. So when the maximum power is 4, we call it by quadratic equation, although it is not in your syllabus. All right? Okay. All of you understood? On the basis of the degree, we can classify the linear equation as 0 degree equation, which is called constant polynomial, linear equation, quadratic equation, cubic equation, and biquadratic equation or polynomial. Now our next slide is 0 of the polynomial. Now for finding the 0 of the polynomial, we have to see that if the polynomial px is having some terms like 2x square plus 3x plus 5. So how to find the 0 of the polynomial? 0 of the polynomial means any value for the x that we can put in the polynomial and our whole equation will become 0. So that value of x is called the 0 of the polynomial. Correct? Look at this. 0 of the polynomial, the real number x. If this real number x is the 0 of the polynomial, in that situation we can see if x is the 0 of the polynomial of fx, then the whole equation will become 0. Just like this example, polynomial px or polynomial fx, we can write it anything. So if it is the polynomial of px, x cube minus 6x square plus 11x minus 6. If we are putting the value of x here 2, what is the value of x here? 2. So if you are putting the value of x here 2, so x cube, that means 2 cube, then minus 6x square, which is minus 6 into 2 square, plus 11 into 2 minus 6. Now when we are calculating it, look at this, 2 cube, which is 2 to the 4 and 4 to the 8, and here minus 6 into 2 square 4 and 4 into 6 24, minus 24 here, plus 12 plus 11 into 2 22, then minus 6. So all the positive values are equals to all the negative value, that means it will give you 0. When you are solving this equation, your whole the positive values and the negative values, as we can see here, and the positive value here, all they are equal. For an example, if plus 50 minus 50 is there, that means 50 minus 50 will be 0. So similar in that case, it comes 0. Although you can simplify it. Look, 2 cube, 8 minus 4, 4, 6, 24 minus then plus 11, 22, then minus 6. So in that case, we can see that these two are negative value, these two are positive value. So simplified it, plus 22 and 8 plus 30, and minus 24 minus 6 will be minus 30. So minus 30 plus 30 will be give you 0. Clear? Now we get the answer 0 for when we are putting the x value 2. That means here 2 is the 0 of the polynomial. I already told you that the 0 of the polynomial is actually the value of x, by which we can put in a polynomial and we get whole equation become 0. So that value x, which is 2, is the 0 of the polynomial. Is it clear? Now we can see the definition. The number of zeros, how many number of zeros in a particular equation have, it is depend on their type of equation or polynomial. By the degree of the polynomial, the number of the 0 of the polynomial is the degree of the polynomial. Therefore, a quadratic polynomial have 2 zeros and the cubic polynomial have 3 zeros. That simply means that how many zeros are possible for a particular polynomial. It depends on the degree of the polynomial. For an example, if it is 0 degree equation or 0 degree, there will be no zero, right? For an example, if it is a linear equation, that means the maximum degree is 1, so that means there will be only and only 1 zero possible. If there is a quadratic equation, the degree of the equation is 2, that means it should be 2 zeros possible. And in a cubic equation, because it is 3 degree equation, or we can call it cubic polynomial, so that's why there will be 3 zeros are possible. Is it clear? Linear 1, quadratic 2, and the cubic 3 zeros are possible. Now our next slide is relationship between the zeros and the coefficient of a quadratic polynomial. Now this is really very important. What is the relationship between the zeros and the coefficient? There are some certain relationship between the zeros and the coefficient which can be given in this form. Look, we all know about a quadratic equation. Let's take any quadratic equation. A standard quadratic equation should be ax square plus bx plus c is equals to 0. When we are finding the 0, that means the whole equation will become 0. Okay, so this is an standard example, a standard quadratic equation. It's written in this form as well, ax square plus bx plus c. Let a and b are the zeros of the polynomial. We can say that here a and b, we can replace it by alpha and beta, because a and b is already there in the coefficient form, right? So we can give it any other quotient, alpha and beta. Now when we are finding the sum of the zeros, so in that case, that means we are finding alpha plus beta. These are the 2 zeros, because I told you that the quadratic equation there will be 2 zeros. So these 2 zeros are in the form of alpha and beta. Alpha is the first zero and beta is the second zeros. So when we are doing the sum of, we are studying about the relationship between the zeros and the coefficient. Zeros and coefficient, right? So when we are finding the sum of the zeros, like alpha plus beta, so it would be the related to their coefficient number. X square coefficient is a, x coefficient is b, and the constant term is c. So the sum of the zeros, which is alpha plus beta, is actually equals to minus b upon a. We can write it here, minus b upon a, although we have represented this small, so you can write it here, minus b upon a. Sum of the zeros alpha plus beta is equals to minus b upon a. So that is the relationship between their zeros, which is alpha beta, and their coefficient, which is small a and b, minus b upon a. Minus b is actually the coefficient of x along with the minus sign. Although in an equation there is a plus sign, but you have to put it here minus sign because it is in relationship. Minus b upon a. A is the coefficient of x square, so that's why it is minus b upon a. So always remember that the sum of the zeros is minus b upon a. Okay, so this is the relationship between the zeros and the coefficient. The sum of the zeros will be always minus b upon a. Second relation is the product of the zeros. Look at this. For the product of the zero, as we can see here, the product of the zero. Product of the zero means alpha into beta, or you can write it alpha into alpha dot beta. So it would be always equals to c upon a. Now there is no minus plus sign. Okay, so product of the zero alpha into beta is always c upon a. So we will write that relation also. Alpha into beta is c upon a. This is the second relation. So these are the two relations between the zeros of the coefficient and between the zeros and coefficients. Is it clear? Sum of the zero minus b upon a, and the product of the zero c upon a. And we all know that c is the constant value and the a is the coefficient of x square. Clear? Okay. So This is really very important. So this, if any algebraic equation ax square plus bx plus c is equals to 0, the relationship between the zeros and the coefficient are alpha plus beta is minus b upon a, and alpha into beta will be c upon a. Okay, now we should move on to the next slide. Relationship between the zeros and the coefficient of the cubic equation. Although it is not in your syllabus, cubic equation, but we can see it is also similar if we are taking the alpha, beta and the third zero. Because it is a cubic equation, maximum power is 3, so there will be the third zero as well, because there are 3 power 3 degree of equation. It is having the 3 zeros, alpha, beta, and the third one is gamma. This is called gamma. Now it would be minus b upon a, and similarly the constant value, as we can see here, this is the ax cube plus bx square plus cx, then minus d upon a. Sorry, it would be, I think, the constant term upon the coefficient of x cube. The constant term is, I think, not given here. It would be plus d. Let me check. It would be plus d also. So constant term d upon a. Okay, although it's not in your course, so not important. Now we will solve out one question based on relationship between the coefficient and the zeros of the polynomial. Now in this question, as you can see here, we have to find the zeros. Find the zeros of polynomial, and the equation is x square plus 7x plus 12, and we have to verify as well, verify the relationship between the zeros and its coefficients, right? We have to verify the zeros and their coefficient also. So in that situation, first of all, you have to simplify this equation, x square plus 7x plus 12. Now as we can see here, x square plus 7x plus 12, we can factorize this quadratic equation by middle term splitting method. Why we can't do it by a plus b whole square? Because as we can see here, the last term is not having the perfect square, so that's why we cannot apply the algebraic identity a plus b whole square, which is a square plus 2ab plus b square, right? So whenever this kind of thing or this kind of equation, when there is the last particular number is not in a perfect square, we will simplify it by the middle term splitting method. And what is middle term splitting method? Look at this. The polynomial px is in the form of x square plus 7x plus 12. Now we have to simplify this middle term, which is plus 7x. So we have to split this 7 into those terms which product will be give you the product of first and the last coefficient. Now what is the first coefficient? Now along with the x square there is nothing, so we can consider it as 1, and the last number is 12. That means the product should be 12 here. It is obviously positive 12. Now the sum of that middle term will give you the coefficient of middle term, which is coefficient of x, which is plus 7. It can be negative also. Okay, so remember the plus sign and minus sign here, whatever it is. So the sum will be plus 7. Now we have to think about those two factors whose product will be 12 and the sum will be 7. How to find it? By making the factor of this 12. What are the factors of 12? 1 12s, the sum is not equals to 7. 2 6s, the sum is not going to be 7 as well. 3 4s, sum is going to be 7. Yes. So that means we have to pick these two factors, 3 and 4. 3 4s are 12 and 3 plus 4 is equals to 7. Okay, so by the factor of the product of the multiple should be the last, that means the constant number, which is you can give it by the product of splitting the prime factor of the constant value, which is 12. 3 4s are 12. So that means here splitting of the middle term, which is 7x, can be in the form of 4x and 3x. Correct? Now we have to take the common between first two terms and the last two terms. In between first two terms, as we can see here, only x is common, so we can take out x common, and the leftover part should be in bracket, x plus and 4. Similarly, in these two terms, before taking the common, you have to put the sign here. What is sign here? Plus. So you have to put the plus sign, then you will take the common. So what is common here? 3. As we know that 3 4s are 12, so that means 3 is present here. So we can take out the 3. Left part is x plus 4. So now the brackets are also similar, so we can take out as a common, and the leftover part x plus 3 will be in another bracket. Now we can say x plus 4 and x plus 3 are the terms of, or these x plus 4 and x plus 3 are the factors of x square plus 7x plus 12, because when we are taking the zeros of this number, x plus 4 can be 0, you can put it equals to 0 when you are finding the zeros or root. We can call it roots also, right? Zeros or roots. So when we are finding the zeros or root of this expression, either 6 plus 4 will be 0 or x plus 3 will be 0. Because the product, this is the production, so this 0 will be multiplied by any number, it gives 0, or when this will become 0 multiplied by any number, it can be 0. So you can say that either x plus 4 will be 0 or x plus 3 will be 0. So when it is equals to 0, x value will be plus 4 transposing on the right side, it become minus 4, and plus 3 transposing on the right side become minus 3. So x is equals to minus 4 and x is equals to minus 3. That means minus 4 and minus 3 are the zeros or the root of the polynomial. That means when we are putting the x value minus 4 or minus 3, the whole equation will be 0 in that situation. Is it clear? Alright. So we can say that we considered alpha and beta are the two zeros. So alpha value, that means the first 0 minus 4 and the second 0 is minus 3. Is it clear? So these are the two zeros. Now if we want to find that the relationship between the zeros and the coefficient, so we have to find the sum of the zeros and the product of the zeros. So we know that if we are finding the sum of the 0 here, so we have to do it alpha plus beta, and when we are finding the product of the 0, we have to do beta alpha into beta. So sum of the 0, in that case alpha plus beta, because we have the two zeros minus 4 and minus 3, which is going to be minus 7, and when we are comparing this minus 7 by the formula minus b upon a, it is coming absolutely the same. What was the equation? Look at the previous slide. Our equation was x square plus 7x plus 12. So I will write here x square plus 7x plus 12 was the equation, and when we are finding the relationship, this is relationship between zeros and the coefficient. Alpha plus beta is equals to minus 7, which is equals to minus b upon a. Look at this, minus b is equals to minus 6, that means minus minus cancel, b value is 7, correct. A value nothing here in denominator, so you can put it 1, a value is 1 here. Yes, x square having the numerical value 1. Okay, now next we can find the product of the zeros, which is alpha into beta. As we know that the two zeros are minus 4 and minus 3, so when we multiply the minus into minus, the product will be plus. Minus into minus will be plus, 4 3s are 12. Now we know that the relationship of the zeros of the coefficients are, product of the zeros are c upon a. This is the relationship which we studied. Now the c value is plus 12 here. Look at this, c value is 12. We know that by the standard equation of the quadratic, ax square plus bx plus c, c value is 12, b value is plus 7, a value is 1, because there is no coefficient of x square. Now the c value is 12 and the a value is nothing in the denominator, so we can put it 1. So a value is 1. Look at this, a value is 1. That is perfectly alright. So hence we can say that here it's proved that alpha plus beta, that means the sum will be equals to minus b upon a, and the product alpha into beta is equals to c upon a. All right. Okay. Look at this. Find the quadratic polynomial whose zeros are 4 and 1. So we can able to find those quadratic equation whose zeros are 4 and 1 by putting the same thing. What is the relation which we have seen? That the product and the sum of the zeros. We know that the sum of the zeros are alpha into beta. So if it is given the zeros only, look at this. These are the zeros. It is given in the form of a zeros. It's not coming in that way. Okay, sir. These are the two zeros, 4 and 1. If we are doing the sum of these, it will be plus 5, and by comparing the sum of the 0 will be minus b upon a. So b will become as minus 5 and a will be 1, and the product of the zeros, 4 into 1 will be 4, and it will be equals to c upon a, where the constant value c is 4 and a, as we can know here, divided by 1. So we can say by comparing these two, sum of the zeros and the product of the 0, a will be 1, b value will be minus 5, and the c value is, as we can see here, the c upon a, which is equals to 4. Now how it comes? Look. Four upon 1, which is equals to c upon a. All right, so